hallmarks of the metric system and the SI system by extension that make it, or that makes them so useful for us to use in science compared to other measuring systems. And that's the use of what are called prefixes. So when you hear the term prefix, just based on your own knowledge of maybe some of the components of the word prefix, where does a prefix go? When you put a prefix into something, where do you put that prefix? At the beginning or at the front, right? That's by definition what a prefix means. So these are going to be things, symbols or designations that we put in front of or at the beginning of a unit to change the size of that unit, whatever that unit happens to be, whether it's a unit of mass or length or volume, whatever. These prefixes are all going to mean the exact same thing. Doesn't matter what you put them in front of. And that's the benefit of using or one of the benefits of using the metric system. So these prefixes are going to be used in the metric and the SI system to change the size of the unit. And again, they're going to be placed at the front. Of the unit. On Wednesday, we had gone through some of the base units that we see in the metric system and the SI system. And we put a little star, or maybe we put several stars around that table. Right? And I said the stars are important because they mean that you have to know those. So do you remember what the base unit was or is for length in the metric system? The base unit for length? Meter. And what was the symbol for meter? Lowercase m, right? Small m. Do you remember what the base unit was or is for mass in the metric system? In the metric system, it was G, which is grams, right? So what we're saying is we're going to take those base units, we're going to put some prefixes in front of those to change the size of those units. And the prefixes are going to mean the exact same thing wherever you find them. There are many metric prefixes that you are going to encounter. Your book doesn't give you all of them. It gives you lots of them, but not all of them. And out of those, we're going to take a look at a few that we're going to see most frequently. And we'll highlight the ones that you need to know for this class. So just like with the base units for the different quantities, there are several of these here that we're going to have to know. All right, so let's first of all take a look at the prefixes that are going to increase the size of the unit. There may be a couple of these that you've heard before. Now we're going to make a little bit more sense of them. The first one is called kilo. All right, so we need to know the prefix, we need to know the symbol, and we need to know the numerical value or what it actually means. So kilo has the symbol small k, lowercase k, and it always means 1,000 of something. And 1,000, if you remember from last time, is the same thing as 10 to the 3, or just simply 10 times 10 times 10. All right, so if we place kilo in front of meter, we end up with a kilo meter, right? And we can say then, we can abbreviate that even more. There's our K for kilo, there's our M for meter. So we end up with km. So if we say a kilometer, we mean 1,000 meters. So 1 kilometer or 1 kilometer is equal to 10 to the 3 or 1 times 10 to the 3 meters. Another way of saying that is that if you have a meter about this big, it's 1/1000th of a kilometer, which is the distance from here to wherever, the Walmart down the road. Right? If you have a kilogram, that means you have how many grams? 1,000 grams. You have a kilosecond, you have 1,000 seconds. You have a kiloliter, you have kilo means 1,000, always, no exceptions. If we go up one more level, we have mega. And mega has the symbol or the abbreviation big M, uppercase M. Right? And mega means a million of something. Or 10 to the 6. 10 times 10 times 10 times 10 times 10 times 10. Right? That's a million of something. So for instance, if I have a mega meter, right? What would be the symbol for a mega meter? A mega meter. So symbol for mega is big M. Symbol for meter is small m. So it'll be big M, small m. Okay, I said this on Wednesday. Capitalization, uppercase, lowercase, makes a big difference. So you really need to pay close attention to how you write these different prefixes and then the base units as well. So a megameter would mean a million meters, or in this case, a megagram would mean 10 to the 6 grams or a million grams. And then the third one that we're going to have you be responsible for is giga. Has anybody heard giga before? Where have you heard the term giga? For your, sorry? Phones? It's storage, gigabyte, whatever. So giga, which has a symbol big G, means a billion or 1 times 10 to the 9. Right? So if we have a giga meter, again we would abbreviate that as big G, small m, right? So we have a gigameter, we have a billion meters. Or we can say 1 meter is 1 billionth of a gigameter. Both of these things here mean the exact same thing. So those are the 3 prefixes that you need to know that increase the size of the base unit. All right, those are the ones that I expect you to know. Tera, we do see that, but nowhere near as frequently as the other 3. So we need to know the prefix, the symbol, and then its value. How does it change the size of the base unit? And those are the 3 most common ones that increase the size of the base unit. On the other end of the scale, we have the prefixes that decrease the size of the base unit. And there tend to be a little bit more of these, several more of these. And we're going to encounter these a lot when we get to talking about the sizes of things that make up the stuff around us. The first one is deci. Right? And deci means 1/110th of something, or 0.1 of something. And deci has the symbol small d, right? So 1 decimeter, for instance, would have the symbol small d, small m. A deciliter would be small d, big L, right? Because big L is the symbol for liter. So we can say 1 deciliter is 1/110th. 1 deciliter is 1/110th of a 1/10th of a liter. 1 decimeter would be 1/110th of a meter. A decisecond is 1/10th of a second. A decigram, 1/110th of a gram. Right? So you put deci in front of something, 1/10th of that thing. Centi has the symbol small c, and it means 1/100th of something. All right, so if I have a centimeter, it would be small c, small m. All right, so a meter is about this big. All right, a centimeter is 1/100th of that. So if you take that meter, you break it down into 100 equal pieces, one of those pieces would be a centimeter. So you have 100 centimeters that make up 1 meter, or we can say 1 centimeter is 1/100th of that big thing. Milli has the symbol small m, and that means 1/1000th of something. So if I had a millimeter, it would be small m, right? So a millimeter is 1/1000th of a meter. So if you take that same big meter, you break it up into 1,000 equal pieces, one of those pieces would be a millimeter. So you have 1,000 millimeters in 1 meter. Well, 1 millimeter is 1/1000th of a meter. The next one is micro. And then micro has an unusual symbol or abbreviation. It looks like a U with a tail at the front. Right? So I'll draw it really big here. I'll try to draw it really big. Let's see if my marker works. All right, that's what the symbol for micro looks like. And you pronounce that as mu. Mu, like that. That's how you pronounce it. And it means micro, or 1/1,000,000th of something. So a micrometer, or a micrometer, it's how it's sometimes pronounced. So micrometer would have that symbol, right? So you'll notice both micro and milli start with M. So you can't use M for micro because it means milli already. So we use the Greek symbol for M, which is mu. So micrometer, 1/1,000,000th of a meter, microsecond, 1/1,000,000th of a second, etc. And then the last one is nano. A nano has the symbol small n. Nano means 1/1,000,000th of something. So a nanometer would have the symbol small n, small m. Right, so a nanometer is 1/1,000,000th of a meter. So again, if you have that same meter, you break it out into 1,000,000,000 pieces, right, which you cannot see with your naked eyes. That one of those pieces would be the length of a nanometer. All right, and so these are the most common prefixes that we're going to see that decrease the size of the unit, and those are the ones that you need to know. Pico, we're going to see a lot less frequently than the other ones. And there are a couple lower than that, by the way. But you have to get into, upper level or higher level chemistry or even physics to really talk about those. Okay, so those metric prefixes are very, very important, right? You already used a couple of them in the lab when you were making your measurements last week, and we never really, explored that in any detail. But we did use milliliters when you were measuring your volumes in the laboratory. Right, you may have forgotten, but that's what you used in your graduated cylinder and your beakers. All right, so I mentioned the last time when we talked about the different measuring systems that the metric system is not something that you see as frequently growing up as you would the US system. But there are places that you're going to see the metric units quite frequently, and a lot of those are in your in the nutrition labels on the things that you eat and drink, right? And when they tell you, when the FDA, the Food and Drug Administration, tells you what the what you should be eating as part of your daily intake of whether it's calcium or whether it's different types of nutrients here. They give you those values in the metric system. All right. So for instance, it's telling you here that your daily value for iodine, this thing, is 150 micrograms, right? Which is a small amount of iodine. Your daily intake of potassium, right, about 3.5 grams, so significantly more potassium than iodine. And then something like magnesium over here. Magnesium is about 400 milligrams in your diet. So we need to make a little bit more sense now of those numbers, because you see them all the time, and you probably don't read the labels on the things that you eat or drink as frequently as you should, right? You really need to know what you're putting in, what you're ingesting. Now, as we start getting deeper into this class, we're going to make a lot more sense of not just the numbers in terms of their relative amounts, but also the names of some of the chemicals or the substances that you actually use. All right, let's do a quick short-term memory check here. 1,000 meters equals, what's the prefix for 1,000? A kilometer, or km. One times 10 to the minus 6 grams would be milli. Milli is 1/1000th. Micro would be the next one, right? So micro is mu. So it would be microgram. Right, and you can accentuate the tail at the front, or the tail if you want to, just to make sure that you don't confuse it with a regular U. You're welcome to do that. Right, make it longer. All right, so just like with the base units for the metric system, I said you have to know those, all right, and you have to know these prefixes as well. So whether you use flashcards or whatever it is, you want to make sure that you get them into your brain. Your book, your e-text actually has an option on there if you explored it to actually make flashcards. Did you guys notice that, your e-text? Okay, so if your mind works with flashcards, I would encourage you to take advantage of those. They're e-flashcards, right? They're not actual physical flashcards, but they work the same way. All right, so now that we've talked about the metric system and we talked about the prefixes, we're now going to take a look at how we can use that information to help us do calculations. And one of the most important things that those metric prefixes are going to give us are these relationships known as equalities, right? And what an equality is just something that is equal to something else. You have to have an equal sign in it to make it an equality. So we've just talked about several of these, right? We didn't call them equalities at the time, but they are. A meter is equal to 100 centimeters. That is an equality. One thing equals to another. They represent the exact same length. The only thing different between them is the unit, right? So 1 meter is equal to 100 of those small units, 100 centimeters. Similarly, that same meter is equal to 1,000 millimeters, right? Those tinier units. So all an equality is one thing being equal to another thing. And the metric system and the prefixes tell you those equalities, as long as you know what each of the prefixes actually mean. So these are some equalities that we find measuring length. We can apply the same reasoning to equalities that measure volume. All right, and I'll just take a look at the one here in the middle. Right, liter, the base unit for volume in the metric system, is equal to 1,000 milliliters. Right, or we can say a milliliter is 1/1000th of a liter. So one thing equal to another thing is all that an equality is. You get them in the metric system, you also get them in other systems. Another very common equality that we're going to see, especially as you're getting into the health field or nursing field, is you'll see this unit being used quite frequently in the administration of when you give drugs to people or different types of medicine, which is the cubic centimeter. Right, so if I had a cube, so imagine this was a cube, and the length of each side of the cube was 1 centimeter. What would the volume of that cube be? How do you find the volume of a cube? You just multiply all the dimensions, the length times the width times the height. So it's 1 centimeter times 1 times the other one. So that would give you 1 cubic centimeter. Which is often abbreviated as 1 cc. Right, that's where the abbreviation cc comes from. And if you take that cube and you fill it with some sort of a liquid, what you find is that that volume that the cube contains is actually equal to 1 milliliter. So there's an equality now between a length, unit of length, centimeter, and an actual unit of volume, milliliter. And we can say, I'm not sure what's going on with my thing here. We can say now that 1 cubic centimeter is 1 cc is the same as 1 cubic centimeter, which is the same as 1 milliliter, right? They all mean the same thing. So when you go to the doctor and they give you whatever 5 cc's of saline or something, it's 5 milliliters that they're giving you, right? Cubic centimeter or cc, it sounds a little more exotic, but it's the same thing. It's a mil. 1 cc, 1 cubic centimeter is 1 mil or milliliter. All right. So we've seen equalities measuring length, equalities in volume. There's also equalities in mass, right? So a kilogram, for instance, is equal to 1,000 grams, right? They're exactly equal to each other. As long as we have that equal sign there, they are equivalent. All right. Let's recap our metric prefixes. Which of these units is larger? Millimeter or centimeter? Milli or centi? Who says milli? Who says centi? Okay, centi is the bigger unit. Kilogram or centigram? Kilo or centi, which is bigger? Kilo. And then deci or mu, micro. Deci is the bigger unit. So knowing, this may not seem like a big deal, but knowing the relative sizes of those prefixes is going to be important when you get your final answer, when you're doing calculations, and you think about whether that answer makes sense or not, right? If you have a big unit, you should have lots of the smaller unit that make up one of that big one, right? And that's something you always want to keep in mind when you start doing your calculations. All right, let's do these two. 1,000 meters is how many kilometers? 1, 2, or 3? 1,000 meters. You have 1,000 of something. 1,000 always means kilo. 1,000 meters is 1 kilometer. 0.01 meters, 1/100th of something. One 1/100th. Centi, exactly, 1 cm is 1/100th of a meter. Next thing we're going to do is actually just an extension of those, or knowing what those equalities are. And that is taking those equalities and writing what are known as conversion factors, right? This is going to be really at the heart of how you approach problem solving in this class. And this may or may not make you feel good, but a lot of the problems that you do in this class just boils down to basic math. It's just math that you're doing, right? And just a little bit of chemistry that we throw in, but it's just mathematics. And how you approach a problem, how you organize it, is just as important as how you solve it, right? How do you make it make sense in your brain so that when you start putting your numbers in, they make sense. All right, so we talked about equalities, which are just simply relationships between two different units. We make them equal to each other. They represent the same thing or the same size. We saw equalities that we can encounter a lot of in the metric system, but we can also see equalities in other systems as well. We can see them in the US system, right? So a lot of times, like I mentioned, when you look at the labels on different stuff that you eat or drink, right, it gives you the amount, not just in the metric system, it also gives it to you in the US system. So, kind of hard to see, but this thing up here tells you the net weight in grams, 142 grams, and it also gives you the weight in the US system, which is ounces. So how do we know? How can we convert from one to the other? Well, that's based on knowing what the equalities are that relate one unit to the next one, but it also depends on using that equality in a systematic way. When we look at numbers in an equality that relate two different metric units, or numbers or equalities that relate two US systems, we consider those as definitions, right? And they are not going to affect the sig figs in our calculations. We talked about this before. We looked at exact numbers, right? Definitions are examples of exact numbers. So saying 1 gram equals 1,000 milligrams, that would be an exact relationship. That's not going to affect your sig figs. Similarly, within the US system, 1 feet equals 12 inches. That is also going to be exact. And then we talked about seconds and minutes. Those are going to be exact as well. So with these equalities that we're going to encounter, especially, and we're going to see a lot of them within the metric system, they are not, when we stick them into a calculation, they are not going to limit how many sig figs your final answer is going to have. Right? We can consider them as having an unlimited number of significant figures. If we have equalities between two different measuring systems, then they actually are going to affect our sig figs, right? So for instance, if we compare grams and pounds, right, this here tells us that we're going to have 3 sig figs. Between milliliters and quarts, this is going to have 3 sig figs as well. And between inches and meters, this is also going to have 3 sig figs. So here we're going from one system, the metric system, to another one, the US system. And in that case, sig figs do play a role. Right? There are always exceptions to these things. The exception here is going between inches and centimeters, which is considered an exact relationship. My point here, so to summarize that, when you have metric equalities and metric relationships, like compare one metric prefix to another one, exact. When you go from a metric to a US or a US to a metric, then typically those numbers are going to affect the sig figs you have in your number and in your calculation. All right, so let's take a look at how we can derive these take a look at these equalities and derive our conversion factors. And it's actually pretty simple when you have an equality. So we know that there's 60 minutes and 1 hour. Is that exact, or will that have sig figs associated with it? That's exact. 60 minutes and an hour. So that's an equality. In 1 hour we have 60 minutes. The conversion factors that we get from every single equality are just simply taking one thing from the equality and put it over the other thing. So we have 1 hour over 60 minutes. That's one conversion factor. And the other one is simply doing the opposite. So take that first one and flip it upside down. And we end up with 60 minutes for every 1 hour. So we can read this as 1 hour per 60 minutes. And this one here is 60 minutes per hour. Right? As long as you have the equality set up at the beginning and they're correct, these two conversion factors should be a piece of cake. Right? Just put one over the other. The key thing that you want to be aware of, though, is you don't just put the numbers, you want to keep track of the units, right? The units are going to help you when you start doing calculations down the road. So keep track of the units. So every single equality is going to have two conversion factors associated with it. All right, so let's take a look at a couple of these. What's the relationship between meters and centimeters? Again, I'm testing your short-term memory. 1 meter equals how many centimeters? Meters to centimeters. That's centimeters to inches. This is a metric to metric. 100, right? So 1 meter is equal to 100 centimeters. Right? The centimeter is a smaller unit. You have lots of the smaller unit that make up one of the big one. So that's an equality. What are the two conversion factors that we get from this? What's one of them? Raise your hand if you think you have one of them. Yes?
1 meter over 100 centimeters.
What's the other one? Raise your hand. What's the other conversion factor? 100 what? 100 centimeters over 1 what? Meter, right? So I'm not picking on you, you want to keep track of the units, right? So don't just put the numbers in, put the units in as well. They're very, very important, extremely important. All right, within the metric and the US system, right? So we say, for instance, 1 inch is equal to how many centimeters now? 2.54. Right, that's going from the US system inches to the metric system centimeters. And again, this here, we're going to have our two conversion factors. We just put one over the other. 1 inch, 2.54 centimeters, and then we just flip it, 2.54 over 1 inch. Okay, it is as simple as that. It's nothing groundbreaking. It's not rocket surgery or rocket science even, if you want it. But those equalities have to be correct. So if you start with those and they're wrong, all your conversion factors are going to be wrong as well. Okay, and you need to know those metric relationships. Okay, relationships like these that go from one measuring system to another one, I don't expect you to know that. Okay, I will give that to you on an exam or a quiz. But you should know metric to metric, all of those prefixes that we mentioned before.